Hello students, in last class we discussed about the magnetic field intensity due to current carrying coil at its center. Now today I will start with one numerical and then we will start to the other topics. Two identical coils P and Q, each of radius are lying in perpendicular planes such that they have a common center. Find the magnitude and direction of the field at common center of the two coils. And you know that if they carry the current I and 3I respectively. So how we are going to find out the solution? We have a two coils, P and Q, they are perpendicular. So say one coil is P and another coil is what? Q. Say this coil is P and this is Q. One is carrying current I. So it's carrying current I and one is carrying what current? What? Root 3I. So they are like this. So what we will see, we will check the magnetic field. From P, if you see right hand thumb rule, the magnetic field will go up. This is the common center. So the direction of magnetic field from P will be up. And from Q, it will be on the right side if you see it like this. So this will be BQ. Are you getting it? And then you have two vectors. The resultant will go like this in between the two lines. And I think all of you know this is 90 degrees. So B by parallelogram law vector BP square plus what? BQ square. Now what is BP? BP is the magnetic field at the center of P coil. And for P coil the current is I. So it will be simply mu naught I by what? 2R. But for BQ the current is root 3I. So it will be mu naught upon 2R into what? Root 3I. So simply we can say is that BQ is root 3 times of what? BP. We can write like this also. So now B will be what? Root BP square. In place of BQ we can write root 3 BP whole square. And you know what we are going to get is root 4 BP square. And ultimately we will get B equal to 2 BP. So this is the answer. And then we put the value of BP. What is BP is mu naught I by 2R. Okay, and 2 cancels out and the final answer comes mu naught I by what? R. So this is the final answer coming here. B equal to mu naught I by what? R. This is the net magnetic field intensity. And then we'll talk about the direction. Say this is theta. So if I ask you what is tan theta can be written as BP by BQ. What it is coming 1 by root 3. If you see it 1 by root 3. So theta is what? Theta is coming what? 30 degree. So certainly the angle also comes here is what? 30 degree. So the two answers we have got from this point. So this is what we are going to talk about magnetic field due to current carrying circular coil. Now what happens when the magnetic field we have to calculate on axis? So for that the next concept we are going to discuss about magnetic field intensity on the axis of coil. Field, that is magnetic field on the axis of a circular current carrying coil or circular current carrying loop. Now today we are going to talk about the axis. Where is the point where we are going to talk it is about the axis. Are you getting it? So point is on the axis of magnetic field on the axis of a circular current carrying loop. We'll talk about the axis and I'm going to draw a loop here. Say this is a current carrying what? A coil, and this is I current. Just see here, and this is the center, and you have taken any point at this, and this is P point. Now all of you know that it is made of current elements. So what we see, we take a DL part here. Are you getting DL? The length element, and IDL is what? The current element. And similarly we'll take DL part on this side, on the opposite side of the diameter also here. Like this is DL. Now do you know what we do? We join them at this point. and both this distance, say this is a position vector of that point, is at 90 degree with dl. And now this is say angle phi, so this will be also angle phi. And at this point, due to dl and s, because the magnetic field is perpendicular to both, so dB will go in this side. And because of this, the dV dash will also go in this side, because it has to be perpendicular to both s and dl, so they will go in this side. Now very interesting thing is that if you see, they will have components of dV, because this angle is phi, this is 90 complete, so this will be what, 90 minus phi, so it is what, phi. Similarly, it is also phi angle. Now dV will have two components. Do you know what are the components? You see it. The components are dV cos phi in this side and dV sin phi in this side. Similarly, we will have for this also dV dash sin phi and dV dash cos phi. Why dV dash? Because we make it dl dash. So I think you are getting it or not. Very simple. This is a loop. You are going to find out at a point P. You consider two elements diametrically opposite. A is its radius and R is the distance. So this is S position vector. Got it? So this is the diagram, and now I am going to start it. Very simple. And I know that what is dB. All of you know that dV at any point is mu naught upon 4 pi I dl sine theta upon the position vector distance. That is, here position vector is what? S. So S square. Are you getting it? Now simply see here what happens in this case. First of all, if you see, dV is magnetic field intensity due to IDL, current element. Are you getting it? So dB will be mu naught I 4 pi dl, and do you know this angle is 90. So sine 90, because I and dl, because dl and r also, it is also 90. So this will be what? S square. So dB will be simply mu naught I dl upon 4 pi s square. Okay, got it or not? This is dV. And similarly, dV dash is magnetic field intensity due to, do you know, the opposite diametrical element IDL dash. And similarly, dV will also come mu naught IDL dash upon 4 pi s square. I think there is no doubt in this. We have two elements taken diametrically opposite. An interesting thing is that the element dl and dl dash are taken same, because again we have to integrate it. So the magnitude of dV and dV dash is same. Remember. So what will happen? dV cos phi and dB cos phi, because they are opposite to each other and equal, will cancel out. So remember, dV cos phi and dV dash cos phi cancel out. Why? Because equal and opposite. I think you are getting it. And then you know that net magnetic field intensity at P, that means at this point, will be due to dV sin phi. Are you getting it? At this point it is in this direction. So we will see that net magnetic field is what? B, and it is integration of dV sin phi. And then all of you know what is dV, mu naught I dl upon 4 pi s square. And from here you can get phi value, sin phi. If you see, sin phi is what? Perpendicular upon what? Hypotenuse A by S. Are you getting it? It is S. So we can write sin phi as A by S. So B, everything will be out, mu naught I 4 pi and this will become S cube, and A, it will be integration of element, always length element we integrate here. So mu naught I A 4 pi S cube, length will be L, and finally I'm coming here, B will be mu naught I A 4 pi S cube. What is the length? The circumference, and it is 2 pi A. And then mu naught I A square 2 pi 4 pi. Now do you know what is S? I can replace S. I think all of you know S is here root R square plus A square. So I'm going to replace it by that, and it will be what? S cube. It is S cube, so it will be R square plus A square to the power 3 by 2. And then you do it like this. Finally you are getting mu naught I A square. It is 2 R square plus A square to the power 3 by 2. This is the expression, very important derivation, very important expression, and this expression is what? B equal to mu naught I A square by 2R square plus A square 3 by 2. I think you remember you calculated electric field intensity due to circular coil on axis. It is just like that. There was dq charge on both the sides, but here we have dl length. So this is the case, and at the last if we say if n turns, always if n turns in the coil, n turns in loop, and then that means B will be mu naught I A square by 2R square plus A square to the power 3 by 2 into n. So this is if n turns in loop. So this will be the concept. So this is magnetic field intensity due to current carrying circular coil on axis. Now one important thing I want to tell you is that if B on axis is mu naught I A square by 2R square plus A square 3 by 2, can we get it at the center? Do you know at center what will happen? If you want to add center, it is at axis. At center what will happen? R will become 0. There will be no position. If you see, this is the diagram. This R will not be there. It will directly come to the center. So R will be 0. You put it here and you will get B center. That is mu naught I A square 2. It will be 0. So we have A square 3 by 2. 2 to cancel out. We have mu naught I A square by 2A cube. A square A gone. Finally B center. Do you know? You have already done it. Mu naught I by 2R. So it here is 2A. This is B center. This is B axis. So now for circular coil, we have two very important expressions. One is at the axis, one is at the center. And now I want to draw a graph also, and there is a graph for B with the distance. And this graph is very important for the coil. And B with the distance for what? This circular coil, and it is like this. Remember because it is a diametrically opposite. So this is the center. You know that it will go like this because it is peak, and it will be positive, and then it will go for negative. So this is the case for positive and negative. This is the B with the axis, which shows that B is maximum at center, and then here it will be plus A and it will be say minus. So this is the case for magnetic field due to current carrying circular coil. And now I have a question here. Say there are a very short question. I am taking two identical circular coils, each carrying same current I, are in perpendicular planes. Okay, and at equidistant from a point, okay, find the magnetic field intensity at the point. And A is the radius given of the coil and R is the distance. Now we can see what it says and what is the solution, what type of solution it has. So we'll see, we'll just check it out. Say one is this and another is this. And this is R, this is R, this is A, this is A. Can you find out it at this? And say this current is I, this current is I. And I think all of you know this is say coil 1, this is coil 2. So where will be the direction? I think all of you know this will be B1. And where will be the direction? It will be up. B2. Now got it or not? B2 will go up and right hand thumb rule. Where is the resultant? I think all of you came to know. This is the resultant. This is 90 degrees. So B will be again the root B1 square plus B2 square same. And B1 and B2 are same. Equal. Do you know what? Mu naught I A square in that 2R square plus A square to the power 3 by 2. So this is the answer. If you put B1 square, B is what? Root 2 B1. So final answer is root 2 mu naught I A square by 2 R square plus A square 3 by 2 into root 2. This is the answer. Got it? So this is the description of this question. This will be the resultant and this will be the answer for. Now we will discuss magnetic field due to a long state current carrying conductor. So magnetic field due to long straight current carrying conductor. Okay, so we'll discuss about that. Earlier we talked about the circular coil. Now we have a straight conductor and say this is a conductor, straight conductor I am talking about. This is say a current carrying conductor. Okay, and you want to find out the magnetic field at a perpendicular distance at point P. Okay, say this is Q, this is Y, and this end is say X. Now what do you do that you join both the ends at this point P. Both are subtending some angle. Say this angle is phi 1 and this is phi 2. Are you getting it? And this perpendicular distance is A. And what do you do that you consider a element here DL. Always we consider a length element, say DL. And then we join this end with the point P and this is what? Position vector. This is R and this is theta. Are you getting it? And this inner angle is say phi. So again repeating, two ends we have connected with point P. The angle was phi 1 and phi 2. Now this is perpendicular distance A of point P. This is R from DL vector and say this length is what? L. From here to here. This length from this point O to Q. Are you getting it? And this current is carrying in this coil is I. I is the current going on. So you have to find out the magnetic field intensity at point P. And you know that very interesting, the conclusion which is going to come is mu naught I by 4 pi A sine phi 1 plus sine phi 2. So this time it is in the terms of the angle phi 1 and phi 2. So how we are going to derive this? So directly we will write, say dB is the magnetic field intensity. You remember, due to what? Ideal, that is a current element at point P. Are you getting it? So what is the distance r? So dB will be mu naught upon 4 pi. Angle is theta, so I dl sine theta upon what? R square, because r is the distance. If you see, r is the distance from dl. So this will be this. Now there is a very interesting triangle, and this triangle is PQO. If you see triangle POQ or PQO, this theta and this phi, because it is a 90 degree, so we can write theta plus phi equal to what? 90. Can we write theta 90 minus phi? Yes. So that means sine theta can be written as sine 90 minus phi. So we are converting it into what? Phi. So that can be written as cos phi. So cos phi, sine theta can be written as what? Cos phi. And in the same way we can check in this triangle what is cos phi. See here. Cos phi will be what? Base upon what? That is hypotenuse. What is base? A. Hypotenuse is r. So we can write A by r. So can I replace r? Yes, r can also be written as A by cos phi. So we know that r can be written as A by cos phi. Sin theta can be written as cos phi. And there's very interesting thing in the same triangle, if you apply what? Tan phi. Tan phi is what? Perpendicular upon base. So L by A. So L is equal to what? A tan phi. Are you getting it? And then if I differentiate DL, so tan phi has a differentiation, I think, sec square phi d phi. Some of you may be knowing. DL will become this. So all three we got in the terms of what? Phi. R A by cos phi, sin theta cos phi, and DL. We will put it here on this. So dV is what? Mu naught upon 4 pi I. Now dl, in place of dl what we are going to write is A sec square phi d phi. So we are going to write A sec square phi d phi I dl. Sin theta, in place of sin theta we are going to write cos phi upon r square. Now what we have written r here? Do you know A by cos phi? So I am going to write that r square as A by cos phi what? Square. So we will solve it. And what we get is dB equal to mu naught upon 4 pi I A sec square phi dl cos phi. Okay. And this is not dl but it is d phi. So remember this is all terms in phi. So this is d phi cos phi upon what? A square sec square phi, because reciprocated. Sec square phi go A to A. So finally, do you know what you get is mu naught upon 4 pi I what? Cos phi and d phi, and in numerator only you have A. So this will be the conclusion. Are you getting it? So this is equation 1. Now net magnetic field intensity you want. Net magnetic field intensity. So net magnetic field intensity, how you will get? You will integrate it. Net magnetic field intensity. For net magnetic field intensity, you integrate it. Are you getting it? So integrating 1, and the limit this time will be from lower end to the upper end. That means this lower angle to the upper angle, that is minus phi 1 to phi 2. Minus phi 1 is below that 0. So minus phi 1 to phi 2. Are you getting why minus phi 1? Because it is below this line. So negative angle minus phi 1 to phi 2. So this will be the terms of integration. So I integrate it. B will come out mu naught I by 4 pi what? A cos phi d phi, and limits are minus phi 1 to what? Phi 2. And finally B will come mu naught I by 4 pi A will be out, and it will be integration of minus phi 1 to phi 2 of what? Cos phi d phi. And I think some of you may be knowing what is the integration of cos phi. So cos phi is what? Integration of cos phi is what? Sin phi. And it is minus phi 1 to phi 2. And then B will be mu naught I by 4 by A. Okay. And then upper limit sin phi 2 minus and sine of minus phi 1. Are you getting it? It is in minus. So finally minus minus will become what? Plus. So 4 pi a, it goes minus inside, sine phi 2 plus sine phi 1. So this is the result of this conclusion. Very, very important. Magnetic field due to a current carrying straight conductor. This is the magnetic due to a current carrying straight conductor. It is B equal to mu naught I by 4 pi A sine. How you got it? You know that two ends of the conductor, upper angle is phi 2, lower is phi 1. Then you took an element, this R, then there is a theta, this is inner angle phi, perpendicular distance A. This is the expression. Do you know this triangle is very important? Triangle POQ. And then you got from there sine theta R and DL in terms of phi. And then you put it here and you integrate in the limits from minus phi 1 to phi 2. You will get this expression. Are you getting it? And last thing I want to tell you in this is that if we have an expression B equal to what? Mu naught I by 4 pi A sine phi 1 plus what? Sine phi 2. Or say if the current carrying conductor is infinite, is a very long current carrying conductor is infinite, means very long wire. So what happens in that case? This will be like this, very long wire. Now at that point, do you know, these two ends will become what? 90 degree, because it's an infinity going. So though the angles, they will not meet here. So it will be 90, 90. So pi 1 and pi 2 becomes what? 90. You put it here. B will be mu naught I by 4 pi A sine 90 plus what? Sine 90. And I know that what it will be? 1, 1 and what? 2. So mu naught I by 4 pi A sine 90 plus sine 90 2 and 2 to the what? 4. So final expression for this will be mu naught I by 2 pi A. So generally this is also used in numericals, mu naught I by 2 pi A. It's for a current carrying conductor if it is infinite. And see here, B is inversely proportional to what? A. B is directly proportional to I. Can we have a BR graph, BA graph, BR graph? Yes, for this it is a graph where we can say that this will be like this. So this is the expression how we can find out magnetic field current due to a current carrying straight conductor. If it is infinite, it will be mu naught I by 2 pi A. If it is finite, it will be mu naught I by 4 pi A sine phi 1 plus sine phi 2. Okay, and thank you. Regularly watch my videos.